What's up, what's up, what's up? Welcome back. Today we are working on writing a QR code decoder from scratch. So there's no real good justification here. Usually I try to say, oh, I have this problem and I want to solve it. And it's like, no, there's no fucking problem. There's lots of ways to do this already, but I just want to do it myself. I'm curious, right? So today is day one. And so I think a good target for today would be to try to get any form of reading of the data, not actually understanding what's in here, but I want to at least go from a grid of pixels like this to some sort of data representation, right? There's some form of blockiness on these guys, right? There's each one of these black and white blocks represents a bit on or off, and it would be nice to go from image to that ones and zeros, right? And so I think the plan of action is we need to start a project. We need to get pixels of an image into something that we can work with in the computer. We need to figure out what the size of these QR code blocks is supposed to be, right? So we can I think the way that we're going to do that is we're going to look for these finder patterns, because I don't think that it's guaranteed. In fact, it's you shouldn't have the edges of the image line up with the edges of the QR code. There's supposed to be some sort of border there. So you have to find these, I think they call them finder patterns. We can use those to kind of figure out where the corners of the image are. Then we can kind of guess what we think the size of each of these blocks will be, and then we can check that against there's one row and one column in the QR code is just alternating black and white. Let's see if we can find an example. Here they have here black white black white black white. So once we have a bit of a guess for what we think the block size would be, we can check that against the alignment patterns, or sorry, the timing markers, I think they're called. So that's the plan for today. I don't really know how far we're gonna get, right? There's a good chance that either this is really fucking easy, surprisingly, and we get there really quick, or it's really fucking hard, surprisingly. Well, unsurprisingly, if it's hard, that's not shocking at all, and we'll just see where we get. Yeah, okay, that's the plan. That is the plan. So step one is get picture into computer. So I think if I DuckDuckGo, I was seeing yesterday when I typed QR code into DuckDuckGo, it just made one for me. QR code, hello world. Oh, that's funny. If I search hello world QR code, it doesn't, but if I search QR code hello world, it does. So let's get this guy and stick him somewhere. I think I made a folder for this already. LMNO PQ, QR code decoder. Any plan for 3D distortions for a photo or just QR code images? That I think is way down the line if we get there. It really depends, because I struggle with I like to say that that's in the plan, that, in my head I do want to look at that eventually, right? But often I get bored of a project before we get to that point, so I don't want to say that's the plan, but it's not the plan. I was thinking eventually what would be kind of nice is to at the very least account for shadows and stuff, get some sort of image processing done, and I thought it would be kind of fun to stick a QR code in a 3D scene, and then you could use Blender to stick the QR code somewhere and see how it looks. You could make a fake bar in Blender, and then we could have a fake little camera that we render in a game engine and look for it. Anyways, I was thinking about stuff like that, but let's not get ahead of ourselves. Okay. So let's see. Let's get it. I guess I should also say we're starting this at 4:30 or something. Okay. So I want to use Zig, because that's what I'm interested in at this moment in time. We've done one project. Why not another? So let's get a little Zig shell up and running, and then we'll make a executable. I think it's init exe. So this gives us a build script as well as a sample main. And then I think what I want to do is I think I want to use SDB image to load the thing. Full disclosure, we're not getting from scratch because I did try using STB image to load an image from Zig yesterday just to see that it was possible. I wasn't quite sure about like C interop, but it's pretty simple. Are you gonna support rectangular QR codes? Dude, I don't even know if I'm gonna support square QR codes yet. We've got a lot of work to do before we get there. So maybe, I don't know, we'll see. We'll keep that in the list of things that we might look at some point. Okay, STB image. Header only library for loading images of a few types. I think it supports like JPEGs, PNGs, GIFs. Oh, am I gonna get into trouble for saying GIF? All of these guys. So I think probably what I want to do is you're supposed to like include this guy. It's a header only library. So you're supposed to define this like implementation define before you include it. But for the purposes of interop with Zig, I think probably what makes sense is to include it once in a C file with the implementation stuff defined, and then we can link against the C file in our Zig build. I think that's probably what makes sense. So we can do like source stb image impl.c, and then here we can go include stb image.h with the implementation thing defined. And then in our build script, we're gonna say, hey, could you fucking add a C source file? And the file is a C source file, which I don't really know what that is. It's got a file and flags. Okay, so here I say file equals something and flags equals something. Probably flags doesn't matter, but file we probably have to instantiate in some way. So this is a lazy path. So I think it's like stood build lazy stood build lazy path. Where does this lazy path come from? What is this thing? Lazy path. This is from, yeah, stood build. I don't know why it's not getting in there. So stood build lazy path. There we go. Init or relative. There we go. Yes, relative. And I want to look at source stb image impl.c. Okay. Impl.c like this. And then, okay, Zig build. Does that work? He doesn't like that. Expected an array or a slice of strings, which are slices. So here, I guess we just say, can you do, oh god, I'm gonna fucking struggle with the syntax here. Array of const u8, and we can build that with this, I think. So we have an array of arrays of u8s, and we initialize that with nothing. Maybe. Maybe? Oh, hell yeah! Wait, that actually worked! Wow, it never works. Okay, fatal error, stdio.h not found, so we need to say, hey, could you please link libc? Because by default, Zig compiles without libc, and it does like basically like syscalls. Well, I guess on Linux, it does like syscalls in assembly by itself. So if we're using a third-party library that's trying to use libc headers, it gets a little angry. So we just say, hey, use libc, please. And it looks like we're chilling now. That worked. And so in our main Zig, we should be able to do const c is equal to c import. And in here, we say, please include stb image.h. And this is going to not compile. Unless it's, oh, it's too smart. It's too smart. We have to try to use it. So, stb, is it stbi load? Yeah, here we go. Basic usage. Do this shit. Okay. So we have var x is a c int, undefined, and I guess it says x. I'm gonna call this width. I don't like calling it x and y here. So we have width, image height, and num channels. We try to load this thing. So you say var image is equal to the file name, which is, I think it's untitled .gif. Yep. GIF. Which one gets me in trouble and which one doesn't? That's one of those ones where everybody has an opinion, but they're not consistent, right? So I can just say whatever I want and piss off half the people. We say we want to get out how large was the image that you loaded. I guess what I should do is I should alternate saying GIF and GIF so I could get to piss off everybody. That's probably what I'll do. So this is how many channels it has. It'll tell us, like, is it RGB, RGBA, just like Luma. And I think that probably for the cases of our thing, we're probably okay with saying, hey, could you please only give us one channel if you can? So we'll say, I think that the options here are 1, 2, 3, and 4. Yeah, here, how many components per pixel? I think somewhere in here it says here. Yeah. 1 is gray, 2 is gray alpha, 3 RGB, 4 RGBA. And so for now, we'll just say, please just give me grayscale. STBI load doesn't exist, but if we say C dot, it should. And then we can say defer C STBI. Do I free it with STBI free? STBI image free image. There we go. Okay, C import failed because STB image doesn't exist because we need to say, hey, could you please add a include path, which is a std build lazy path relative source. So here we're saying, hey, we have a header file in there. Could you just figure out where it is for me, please? Okay, so it built. And we can run it and nothing happens. So maybe we can say, try to get like some useful info here. Let's just like start by saying std debug, or is it, yeah, debug print found image of x by y num channels, like this. And so this is just image width, image height, num channels. Okay, so 100 by 100, 4 channels. So that's kind of interesting. We asked it for 1, and it just gave us 4 anyways. So I guess this, like, load function, desired channels, is just kind of like, I guess it can fail. I don't know why it would fail. So the return value, blah, 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 points to pixel data, y scan lines of x pixels. There's no padding, regardless of format. The number of end components. If desired channels is num0, channels and files otherwise. If not desired channels is num0s, blah, 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 that would have been output otherwise. Okay, wait. If desired channels is non-zero, channels and files has the number of components that would have been output. Ah, so you're right. I guess it tells how many channels the original file has. So it's doing the conversion for us under the hood, but then telling us, hey, just so you know, it was RGBA. Okay. So if that is true, right, there's like 2 options here. One is that num channels is 4 and we think it's 1. And so in that case, if we try to print out the image going byte by byte, it's going to do the wrong thing. And the other option is that num channels is 1 and we think it's 1 and it'll work. So maybe what we can do is we can just like do a quick sanity check where maybe we iterate over the pixels. So let's just say for 0 to image height, we call that y. And we can do the same thing for width. And this is going to be x. And then we just like find the pixel. So var pix, or luma, I guess is what we're calling it, because it's a grayscale image. And we just look at image. What is the type of this guy? We have to be careful here. This returns STBI UC, which I assume is U8. Yeah, okay. So here we just can say image plus x plus y times width plus x. Yeah, dereference this. And I guess we don't have to dereference it. We can just use it as an array like this, probably. Okay. So this should be a U8. So maybe we'll specify the type, even though Zig will like auto-deduce the type for us. If I say that it has to be a U8, if we did like a library update and the type changed, then like the compiler would yell at us, which is a good safety check. Okay. Because otherwise maybe this math wouldn't work out, right? And I guess we have to multiply by num. Well, we don't multiply by num channels here. We're expecting grayscale. And then I guess we're going to say if Luma is greater than 128, like if it's like white, we'll try to draw something that looks kind of white. So maybe like an O. Maybe an at symbol. Yeah, at symbol's pretty dense. And otherwise, we'll print a space. So like this, and then every line, we have to print a new line. And let's see if this looks reasonable. So he's complaining that these guys, I guess his ranges, he's expecting U sizes, but these are ints. So I guess we can do as U size and then int cast or something. I think this is the Zig way of doing this. Gross. Maybe I should name them. That would be nicer. We'll call this image height I32 or I or something C, image height C for C int. And then we can say const image width as a U size and an int cast of image width C. Same for height. And then hopefully everything is kind of nicer. Expected 2 arguments for debug print. Sure. Throw a little one of these guys in there. Okay, that's a really good sign. So we do have a QR code. It's kind of, I guess fonts are kind of taller than they are wide. So maybe we do 2 for each of these. And then it'll look a little more square if I zoom out. Yeah, there we go. Okay, cool. So we have something. Our colors are correct. And so now I guess we have a QR code. Okay. In my to-do, I had set up some form of visualization before actually doing anything. Because in my head, I'm kind of imagining we're going to try to find these like markers, right? We're going to try to find this, this, and this. And we need like some way to determine if that's like correct or not. So what I was kind of thinking was we could like embed the image in an SVG, and then in our then we can just like manually make an SVG that kind of draws the centers on top. Because then we'll have like, I think I've been doing too much of these things where we're like working with complex, well, not complex, but just parsing stuff with nothing to look at is kind of like really fucking boring and harder to tell what's going on. So if we can like quickly bang out a visualization, that's like better, is kind of my thoughts. So I think let's just start with being able to draw a dot on top of the QR code. And I think I was Googling this earlier, but I haven't tried it. I think there's a way to like embed like a PNG in an SVG. I think they have like an image tag that you could like base 64 drop something in, or have like a reference to another file or something. Yeah, here you go. So they have like, hey, here's an image, and could you put this at this specific spot? So I just want to see. I haven't tried this. Let's look at test SVG. Let's just paste what they did in here. And then can we do like href is just like an adjacent untitled GIF, and can we put this at like x0 y0 with width 100, height 100, fuck your transform, and our thing should be 100 by 100 as well. This feels like SVG can do everything except tell you how wide some text is. Classic. Does it need this X-link? I haven't seen this X-link before. What is that? X-link. Doesn't really tell us, but maybe you go to this specification and it says what it is. This is an XML namespace defined in Xlink specification. For more information about blah, 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 blah. XML linking language, which allows elements to be inserted into XML documents in order to create and describe links between resources. Okay, so we kind of have to say, hey, just so you know, we're trying to link something, and you need to be aware of this thing. And then I guess our parser probably changes behavior if it sees this, probably. Okay. I don't really know if this is going to do anything sane, but we can find out. Can we dolphin here? And does this test SVG? Oh, don't open it in fucking GIMP. Oh, okay, but that's a good sign. So there is a QR code in here in test SVG, and so we could do something like, okay, first of all, do I not have like a better application for this? Like graphics, Gwenview, right? Is this not what I'm... image file name is empty. So, oh, maybe it can't open an SVG. That's fucked. What can? Open with, I guess, Firefox? Yeah, we'll do this. We'll open it in Firefox and refresh. That seems fine. Okay. So, just for proof of concept, if I wanted to, like, make a thing where on top of this image, I draw, like, a circle, with, like, X equals 25, Y equals 25, R, I think for radius equals, I don't know, 10, and fill equals green or something. I think this is valid. I guess we'll find out really quick. Okay, so that's good. I think it's center X and center Y, not X and Y. Okay, cool. So we have like some way to output something, right? And so now what we can do is, as we start looking for the centers of these guys, we can like generate an SVG that puts like dots where we expect the centers to be. And so now all we have to do is generate this SVG. If I take this Xlink out, does this still work? It does. If I take this XMLNS, that doesn't work. Okay. Okay. Cool. So I guess... honestly, I've only seen like 3 programs that have more or less complete SVG support: Chrome, Firefox, Inkscape. Yeah, I guess that doesn't surprise me. If they just are like complex beasts, then a browser being the guy who does it right, it's like that doesn't surprise me. Those guys they have lots of shit in them. Okay. So I guess, let's make some way to like interact with XML files. I guess like SVG files would be the normal way, but like, I guess SVG is a subset of XML, and I want to think of my thing as an XML generator, not an SVG generator. So we need some sort of like way to generate. I mean, you could just type the XML, but I would prefer something that like is like a little nicer to use programmatically. So I'm kind of thinking, what I've done before here is I've done like XML builder is something. I think that this has to be a function, actually, because we're in Zig. And I think what I want this to do is I want this to, like, wrap some sort of form of, like, writer, right? So I could take in, like, a file handle, or I could take in an array, and I can just, like, write things into that thing with no allocations. That's kind of like what I want to do, like, stream the data in, I guess. So we have maybe a writer, which is a type, and we generate a type. Because in Zig, your generic types are functions that generate new types based off inputs. Isn't that fun? And so we're going to return some struct, and he is going to have an internal writer, which is the writer. And let's see. I have XML PTSD. I started using preferring templating engines to generate XML in many use cases. It's not much more obvious what happens compared to DOM manipulation. Templating engines. Okay, so you're talking about... Okay, let's just pretend I have no context. You're talking about templating engines as in, like, some, like, DSL that you use on your backend, and then you feed in some arguments to the template, and it generates XML, I guess. I've never really, like, worked with templating engines, but I think that's what they are. Okay, So I'm gonna have some sort of function that initializes this thing, and he's gonna take in a writer, and he's going to return our XML builder, and there's an XML domain-specific language, XSLT, it's NetMerfuel. Oh, I've seen that, because like sometimes if you want to extract properties from XML, I've used XSLT path specifiers, and they're like, yeah, they're nasty, NetMerfuel. But luckily, we're only generating stuff, and if we're generating in the browser's rendering, all of the hard parts on the browser side, right? We can just write whatever the fuck we want. And if we're like out of spec, then like, do you know how much out of spec shit there is in the world? The browser has to handle it, so we can just be as shitty as we want. Okay, so here we take in our writer, boom, boom, and like, what does our API look like? I think we want to be able to like add a child node, add node. And he's going to return nothing, I guess. In my Rust world that I like to live in, what I usually would do here is I would make a type that's like XML builder is like consumed. I've already forgotten how to write Rust functions. I would have like add node takes in self by non-reference and like returns a new node, and then the node would have like a finish function that returns back the XML builder, because I like the idea of like having no APIs that you could fucking call in the wrong state, right? Because like if I'm in the state where I'm writing like value like thing with like attributes x equals 4, y equals 5, kind of like while I'm in this section, it's invalid for me to add like, I can't write like thing2 in here. That's like, whoa, no. We have to be like out of the attribute section. So the Ruster in me wants to do it this way, but I think I don't want to do that. So why are we doing SVG, by the way? Because I just want to like draw stuff on top of a picture, and SVGs seem like the simplest way to do it. Simplest from my perspective of putting graphics. Like I want like put shape on thing, right? You could like load the image into an OpenGL texture and then write like a graphics shader to like draw the thing. You could do like a software rasterizer where you like go pixel by pixel and then you draw the circle yourself and then like export a PNG with like some image writer. But really I just want like, I think SVGs are like the simplest way to just be like, I want shape on picture now, please. At least from my perspective. Okay. So we are going to add a node, and we're going to check the state. So we're going to say like const state is an enum. And I think that we only have to worry about if we are within an attribute. Draw it in CSS and embed Electron. No. I think we only have to care about attribute, others, and maybe finished. Maybe if we've like completely finished the XML, we've popped all nodes, then I think that it's invalid to add more. I'm not really sure. I think that XML needs like one top level thing. And then we can like look at our state. So we're gonna look at our state, and his initial state is gonna just be other. When we try to add a node, we need a self type. Const self is equal to this. There we go. We're going to check our state. And it's valid to add a node if we are in the other state. So I guess we say like dot other, we do nothing, else we stood log error, cannot add node while in this state. Yeah, and then we can just write self.state. Yeah. Const std is equal to import std, boom. Okay. And then we return an error. So we can just say, maybe we'll make an error type here. I haven't been making error types, but I should be. XML error is an error that just has invalid state. then I put a comma here, I guess, and then this becomes XML error like this. Okay, and then we return XML error invalid state. Boom. Okay. Now we can add a node. So in this world, all we have to do is write all, and we just write. I guess we need like a key to take in. So this is going to be a const u8, and here we're going to write the key. It's just like this, I think. Sure. Yeah, and this is gonna have to be try, which means that our XML error has to be an error union. So I think it's like this, and then I have to take in like what is the output of a writer. So we can just go to std io writer, and then he has a write all function who's gonna have a write error. Yes. So we're gonna just say, I guess here, since the write error is like, where does this come from? Who defines this? Oops. Write error comes from here. Oh, so it's like a fucking argument to this guy, and then I have to, okay, so I think that this means that I have to do something like, do I put this here? And then I say const write error is equal to writer dot error, and then or write error like this. I think, because like technically this writer error could be different depending on the generic inputs. I guess. I'm not really sure if that's right, but we'll find out. Okay, then we have like add attribute, right? And so we're gonna take in self, we're gonna have some key, const u8, we're gonna have some value, which I will just force to be a string for now, but probably in the future, I'm probably gonna want this to maybe also be, I might want to like pass in integers here. Not really sure. Gotta keep an eye on this channel. Gotta go to sleep for now. Have a nice time. Well, thanks. Appreciate it. Catch you on the next one. Well, good time to plug YouTube. If you're sleeping now, you're probably going to be sleeping now most days, and I stream at the same time most days. But VODs will go up on YouTube. Okay. So here, we are only allowed to write stuff here if we are in the attribute state. Otherwise, we should log an error and return. So we can say, cannot add attributes while not in attribute state. Okay. And so this is just going to be like try self writer write all. And we're going to do like prepend a space and then do key equals value. Yeah. Yeah. And so this is going to be actually a string here, and then we're going to have to take in key and val. And then we're going to have some sort of like finish attributes thing. Enable autofix true and ZLS configs handy. I've actually intentionally turned that off. I fucking hate it. Dude, I lose my fucking mind when anything touches what I wrote. It pisses me off so much. In like every single program that does it, like, holy, like even like just bracket matching in Visual Studio Code, it just like fucks up. And then you're just like, you have to delete stuff that you didn't type. It's just like, fuck, just don't touch what I wrote. Don't touch it. But I can see an argument for people not feeling that way. Okay, so when we finish the attributes, I think that okay, so there's like a few forms here, right? You have like circle x equals 5, y equals 4, and then you close this thing like this directly with like a slash thing, and this is like self-closing, or you have like this other version where you have circle like this and then some stuff inside. So I guess finish attributes is we're going to call it like this one. Autofix is not auto-format, by the way. Yeah, I know, but still, it's just like it just moves shit around. It bothers me. So here we're just going to say self-writer, write all. And I think that we just write this. I think. And then we change our state. And then we'll have like a function finish node. Take itself. And this is the only place where we actually have to care about states. We'll have like, you know, if we are like here, then we have to pop the tag from a tag stack and write this guy. But if we're in the attribute section, then we'll just do like a self close. I think is probably the same thing to do here. So we'll say switch self state. And if we're in attribute, we'll write out a self-closing thing. I think both of these I want like states up or spaces up front, I think. And I'm actually starting to think write all is not the right fucking API because he doesn't take in arguments here. I think that we're trying to do print on basically everywhere we've written write all, we want print. Yes. Yes. Okay. What I don't like is when I change the config of a program running, when I close the program, it actually saves its own things and my modifications are deleted. Oh yeah, that stuff is kind of annoying too. Okay, so if we're in the other state, I guess we punch in a new line and then write /string, where the string that we're passing in is the tag. And that means that we kind of want to like keep a tag stack. So std array list const u8. This is a little sketchy. Our tag stack is going to be holding references to the strings that we use to generate them. But I think that for our purposes for now, I think that everything's going to be a static string anyway, so it doesn't fucking matter. Which means that our initializer needs to take in an allocator. Which means that we need const allocator is equals std mem allocator. And if we have a tag stack, that also means that we're going to have to free some memory later. So we have a dinit function that takes in itself and calls self tag stack dinit. Here we have to create this guy, tag stack is equals self, or I guess here we'll make a tag stack type. So this is this, and then we don't have to type out that generic bullshit twice. Boom. And then we have tag stack init alloc. Boom. Boom, boom, boom. Okay. So here now we can pop the tag. So pop here. Yeah. Var tag is equal to this. And I think probably this might not be valid, so it's pop or null. Probably. Then okay. Else we need some sort of like fix me yell when no nodes to finish. Here we want to use the tag. So here we say var, we'll call this tag optional. And then here say var tag is equal to tag opt, or else we return an error. So we'll just return XML error invalid state, and we'll say no child node to close. Okay. Okay. And I guess probably when we add a child too, we're probably going to want a new line prefixed. Do we? Maybe we postfix the new line when we finish the attributes. Yeah, okay, maybe that. I think that all lines up. Not really sure. It'll become pretty clear pretty quick. Okay, is there anything to think about in here? Add attribute, add node. There's a missing state change here. So this is, we start in the attribute state. And then the last thing is we just need like a pub function finish. And actually, maybe we'll do this instead of the dinit function. XML error like this. Oops, or. And this should also say XML error here. Like this, boom, okay. So here, we're gonna kind of like just while self tag stack items len is greater than 0, self finish node. Yep. All right, okay. So fuck Dean here. And now let's try to like create this thing. So we'll say const or XML is equal to import XML zig. Now we should be able to generate some sort of SVG that is like valid. So we'll say var SVG builder is equal to XML builder, which needs to be public. I guess we need to do that thing where in Zig, you have a function, and this is a function that generates a type based off of the type of a writer, right? But when we actually use this thing, we just want to pass in a writer and not worry about it. So what do you call this? Convention is to write the same thing again, but with a lowercase here, because lowercase functions return values, uppercase functions return types. And so you can then say, I'm going to take in a writer that is any type. And I'm going to return an XML builder with type of writer as the input to the type generating function. And then here we can just return XML builder type of writer dot init alloc and writer, which means that we need an allocator in here as well. Okay, which means that here we haven't actually set up an allocator, so we can say var GPA for general purpose allocator is stood heap general purpose allocator. We pass in a configuration that is empty, and then we initialize the structure. We de-initialize the allocator at the end of function scope, and then we pull out an allocator. And then here we can say we want a XML builder with an alloc and a writer. We don't have a writer yet, which means that we need to make one. Interesting choice of Zig to change expected returns based on case. I mean, I just want like sanity checks to make sure that I'm not like fucked. Oh, no, you're saying change return types based off case. You're talking about this. Maybe. It's because they don't have like a templating system, which I think actually makes a lot of sense. Like you have functions that generate types and functions that generate values, and so you have to kind of like do this bullshit. But yeah, it's a little odd. Okay. So when we generate an SVG, I guess we'll just start by looking at our test SVG. And here we will just start by shoving all this shit in here. So we have try SVG builder add child. Oh, first we need to make the writer. I forgot that part. So let's just do a stood fs current working directory. This is how you open a file in Zig. You get the current working directory, and then you create file. And the reason you do this current working directory thing is it lets you use relative paths. It's also convention, not built into the line. Yeah, for sure. So we're going to create a file that's like test2 SVG, and we're going to have no options here. And then we're going to say var SVG files equal to this. SVG file writer should give us the writer that lets us shove shit in there. Boom. And then here, now we should be able to do something simple. Let's just start with SVG, defer SVG builder finish. And then I guess we need to catch the error here. So here we say stood log error Failed to finish SVG builder. Failed to finish writing SVG. We'll just say that. Okay. SVG builder, and then here let's try just doing like SVG builder add node SVG. Let's just see what happens there. Okay, so lots of things that aren't right here. We're gonna go through them one by one. This should be allocator, not alloc. You can put a function call in the return type that uses comp time args and makes the type. Oh yeah, Zig is wild. Yeah, it's pretty fun. Pretty fun. You can skip the SVG version XMLNS if you hate your browser. Yeah, I mean, I don't want to, even though I'm trying to say, like, look, we can be shit and the browser will make up for it. I don't want to, like, intentionally be shit. I just want to accidentally be shit. Okay. Next compile. Error is ignored. He's such a whiner, this guy. Expected 2 arguments, so that's here. Forgot to put my parameters that are empty. Expected type found function comp time type, so in our XML, I forgot that this guy, XML builder doesn't exist at this point, because XML builder is like the function, not the type. So here we use self instead, and I think we're good. Okay, what's next? Value of whatever the fuck it says. Ignored. So I was in Rust mode and just typed the thing. I have to type return here. Return. And then here, I can also have an XML error. Oh no, there's no XML error on initialization. We're good. Tag stack init. No field named tag stack because of course there isn't. STACK. Boom. Oh, okay. So that did something. And can we look at test2 SVG? We do have this thing that opened, but he didn't close himself, which is bad. Let's get rid of this, like, where we print the SVG. When we finish, he tried to, oh, we never pushed the tag stack, so that's probably why he didn't error out, which is what I would have expected. So self tag stack append key. I guess the error order should be we try to push the stack. If we fail to push the stack, we don't write anything. If we fail, then we try to write, and if we fail to write, we don't change the state. I guess, technically, in this error case, we should self-tag stack pop. Right? Because here we're like, hey, I have this thing in my tag stack, but we didn't actually fucking write it. So do we pop the thing? I guess, but in that case, like, you don't know if it failed because it wrote half of it or all of it. So really your whole writer is just like in an invalid state at this point. Fuck it, I'm just not gonna worry about it. You know, you could do, probably like if I was a good boy, I would do this. I would say catch E, and then I would say self state is equal to invalid, and then I would return error. Fine, I guess I've already written it. Ugh. But I don't really want to do that everywhere. No, I'm not going to do it, because then I have to do it at every place. We're just going to say, anytime there's an error in your writer, if you try to do anything and errors out, fuck you. The whole file's invalid. Figure it out. That's what we'll say. Okay. Sig build and run. He doesn't like... Oh, out of memory is another option here. So somewhere, when we write this guy, he's got an error that he can return, and it's an allocator error. So here we can say or allocator error. We have some leakies. So this is coming from... we need to increase the fucking backtrace length. So I think in here, you can say dot stack trace frames 99. And then when it allocates, it writes down the backtrace from where the allocation came from, and it stores that along with the pointer, so that if there's a leak, it can, like, backtrace it later. You can check if there's an error without unwrapping, and also error defer to capture the error. Oh, yeah, I guess I could just error defer at the beginning of the function, setting the state to invalid on every function. That's not crazy. That feels a lot better. Maybe I would do that. So this is when we're not clearing the tag stack. Because here I wrote defer instead of defer, which I meant to write defer. Okay, there we go. No leakies. No leakies, no squeakies. That's what I always say. It's my motto. Okay, so now we ended up with an SVG element that self-closed itself, which is good. That's like expected behavior. So now let's say try SVG builder finish node. No. Finish attributes. Then when we finish, it should this should close this without the self-closing tag, then immediately put a new line and nice. Yeah, we're chilling. We're chilling. That's not bad at all. Okay, now let's add some of those attributes in. So here we can just do like go into the right indent level, QQ, start a macro, then we say try SVG builder, add attribute, put a quote, find the equals, replace the quote, put a comma, end of line. There we go. Okay. So now we have an SVG that has version 1.1, XML namespace, width, height, okay. And then all we wanted to do after that was we want to add a child node. And this is going to be image. Yeah. Okay, and then we just do the same shit. Paste, yep. And then I think, nice. Macros still working. Then here we finish the node. And does that look good? We've got SVG, blah, 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 image, blah, blah, blah. But then we've got like double self-closing tag, which is a problem. Finish node. This is doing the right thing. So if I'm in attribute states, I do this. Otherwise, I pop from the tag stack. Okay. Add node. Is he pushing to the tag stack? He is. Oh, it's when I finish attributes, I have to, oh, I do change my state here. Something's wrong. Something's wrong. I just want to double check that. Okay. So I guess what we should do is we can breakpoint here. I guess zig builds, blah, 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 blah. We can GDB, zig out, boom, 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 break on here, run it, and there's print self tag stack items. So this has a tag stack of 0 items, which seems like a bug at this point, because we haven't written out the SVG final tag yet. So maybe we'll break on, okay, add node, push to the tag stack, great. Then we add attributes, blah, 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 finish attributes, we change the state, but the tag stack stays the same. Finish node, pop or null. So what the fuck am I missing? What am I missing? GB, break here, run, P, tag stack. Length 2, okay. That makes sense. Oh, I'm an idiot. I see where the bug is. I see where the bug is. When I am here, after I finish one guy, I need to change my state. Because it was writing 2 self-closing tags instead of 1. There we go. So now we have SVG, image, SVG close. Perfect. And if we open this guy, which was here, I'm concerned because he doesn't seem to be doing what I thought. Oh, because this is test2.svg, not test. Cool. We're chilling. Okay. Okay, so all of that, we have some way to write an SVG file, and now we can just do something like, if we wanted to add that circle back in, we could add a circle, set its CX, CY value to 25, 25, set its radius 50 or 10, and set its fill to green. And that renders okay. Sure. There's some like new line problems in here. I'm not going to deal with those right now. I don't want to fucking worry about it. Because I just want to make sure that we're moving. Okay. So now, what I would like to do is generate, like maybe we want to like wrap this a little bit in something that just allows us to easily think about things in like QR code space. Or maybe pixel space. Yeah, okay. Let's just do const visualizer, we'll call it for now. And inside, he's going to have a XML builder, or SVG builder, which is a XML builder. So I guess we have to make this a generic function. Or we can just say that it's going to be fixed to a file. I'm okay with that. What is the output type of this guy? Okay, let's just do this. So SVG builder is just going to go to a std io writer, std fs file, std io writer. Oh, fuck. Okay, fine. We'll make it generic. We'll make it fucking generic. Fine. Fine. So we have a comp time writer, which is a type. He returns a type. We return a struct. This is SVG builder, who is a SVG builder. No, XML builder. XML.xml builder with typewriter. Okay. Pub function init. He is going to return something. We're going to slap an SVG. We're going to say, hey, you are an SVG unconditionally. I guess here we are going to take in the writer. Man, this way of doing generics is so nice. Yeah, it's not bad. It's not bad. I do like it better than C++, this template system. What's really fucking cool is I've looked at this a few times, but if you look at the general purpose allocator, this is so fucking cool. So they take in like some configuration at compile time of like things that you might want to configure your allocator to, like enable memory limits or like make it thread safe. And what's fucking crazy is they actually change the type layout based off of that configuration. So they can say, hey, this requested size, if you have a memory limit, is a use size, otherwise it's void. Isn't that fucking crazy? So your like struct memory layout just changes based off of some if condition in a function. And that's just like, boom. Like if you fucking do that in C++, oh, bad boy, are you in for a bad time? It's possible, but you're not going to like it. Whatever you come up with is not going to be something that you understand. Okay. Okay, so we need an allocator here. Boom, boom. So we need const allocator, std mem allocator. I guess here we just pass in the writer like this. We set our traits. So here we probably want to take in our like width and height, I think. Which means that here, maybe we do add in a version of this function that doesn't take in a const u8. So maybe we'll do like add attribute num, where this guy can be an any type, but he prints a D here instead of an S. And then I guess we'll factor out function like ensure attribute state or check attribute state, I guess. Yep. And he's going to return XML error or void. And then he can pull this shit out here. Boom, boom. And then we can just write try check attribute state. Boom. All right. Okay. Which means in main, now we can pass in attribute num, and we can pass in a width and a height. Cool. And I guess maybe we just take in like the image path here too. And we can just kind of throw this in there as well. So here we have x 0, y 0, but the attributes width and height are going to be numbers that are width and height dependent on the image. We're going to href the thing. Cool. And I guess here we're going to take in the image path like this. Okay. So then we're going to create our visualizer. Instead of creating our SVG builder, var visualizer is equal to visualizer.init with alloc and SVG file writer. Perfect. And then we should be able to do like something that's a little more simple, where our visualizer we can just say, first would say pub function finish is going to take in self as self. He's going to return nothing, and he's going to call self SVG builder finish. Okay. But more importantly, now we can do like higher level APIs like pub function circle, and we'll just take in self. Maybe we'll call it draw circle. And we'll take in CX as a float, CY as a float, radius as a float, and fill as a, I guess a string for now. And then we can abstract this stuff away. Boom, boom. This all says self. Oopsies. Like that. Here, he doesn't have this thing, self, so we have to make it. Const self equals at this. And here we need to say add attribute num for all of these guys and pass them in. There we go. Boom. Simple. So now we have visualizer draw circle with 25, 25, 10 green. And defer visualizer finish. Sure. Defer like this. I don't know. It's fine. It's fine. Okay, let's zig build and double check that it's making something that is sane. So our visualizer type of SVG file writer. Gross, but will live. Here we forgot to return SVG builder is equal to SVG builder. We found expected type found function comp type. Right, so here we weren't supposed to write visualizer, we're supposed to write self. Expected 5 arguments found 2, right? So here, when we create our visualizer, we're going to set the width, image height. What am I missing? Oh, and the path. So this is untitled GIF here. Okay. Draw circle. He doesn't like this. No field or member function name draw a circle in this thing because I didn't write try. Error is ignored in 37. Right, so we write try here. Expected 1 arguments found 0 on check attributes. So this should be self dot on both of these. Okay, and our SVG looks good. If we refresh it, it looks like it's rendering, and let's just double check that if I change like from green to red, it's still running something valid. Yep, okay, cool. Cool. Okay, so that took a while, but I think it's worth it. I think it's worth it. Because now we're going to be able to like try doing stuff, and it should be really easy to just like slap some quick visualizations on stuff, right? Drawing a circle, super fucking easy. Super easy. Okay, so what's next? I guess if I understand correctly, I was like Googling a little bit about how are you supposed to like find these position markers? And it's not super clear, because the specification for QR codes is an ISO spec, and so you have to pay like $200 to read it. So fuck them. I'm not going to pay $200 to just like figure out how to implement some standard. But there's like a lot of things that you could do here. But a simple algorithm is you just walk line by line in one dimension, and you look for the pattern 1, 1, 3, 1, 1. And the QR code, I think if I understand correctly, is like saying, I won't have that pattern anywhere except for on these finders. And so I think even if this was rotated a little bit, you could imagine that if you're going through the diagonal, you do still have that 1, 1, 3, 1, 1 pattern. And so I think that if we like do it like horizontally and vertically, we'll have like ranges where those are valid for both X and Y. And then we want to like probably find the center of those ranges. Probably. And I think that that'll do something kind of sane. Yeah, I think. But I guess we'll find out. Wherever this guy should be, we should be deferring free way up here. I will never understand why they're allowed to charge respect. It doesn't make sense to me. Yeah, I think the argument is that, from what I've been like Googling the past few days, because it's pissing me off too. I'm just like, this is bullshit. I think I saw somewhere that they pay, like the money doesn't necessarily go to ISO, but it might go to the people who wrote the spec. And so like to give incentive to write good specs, maybe. But yeah, I mean, I'm not gonna fucking pay them. Like, fuck that. Like, it's ridiculous. Okay. So let's start by, I guess we'll write a function that's like run length encode, I guess that's it. Run length encode, like this. And okay, so here's what I'm thinking. I'm thinking we're going to be doing this both horizontally and vertically. So I'm also kind of thinking that you can abstract away the iteration part of this from the actual run length encoding part. Maybe that's a little bit too crazy, but I'm going to do it anyways. Because then I'm also thinking like, what you're going to have like you're also going to have like parsing of the image, right? Where you're going to say like, oh, do I want this thing to be like, what values am I converting to what values, right? Right now we're saying for our little test that we did before, it was like, if the color luma is greater than 128, true, is like maybe something that we're going to do. So I kind of want to like encapsulate that logic in the iterator as well. And that makes our run length encode pretty straightforward, where we can just say we take in some iterator, which is going to be some any type. And we're going to return an array list of lengths. Yeah. And so the idea is if you have like 1110000000111, this guy should return 3 for this many ones, then 1, 2, 3, 4, 5, 6, 6, 3. That's what we're expecting to get out of here. And then if we see the pattern 363, then we can go like, oh, that's a spot that we like. So he's gonna take an iterator. I think my language server crashed. I think I saw something go crazy there, so I'm just gonna restart it there just in case. And we're gonna do something like, oh, it's something else crashed because my indenting is not working. I'm just gonna close everything and open main. Okay. So we can do like while it next, we get some val. We can say var previous is equal to it next. Or maybe we say count. Previous. Count equals 1. Yes. Yes, 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 yes. And then here we say or else. Or I guess we say we have some return type, and he's going to be a std array list. U64, initialize with some allocator. Yep. And if this guy has nothing that comes out immediately, I guess we just return an empty list. I think that's reasonable. Then we can just say if val is equal to prev, count plus equals 1. Otherwise, we put a thing into the array list. We put the count into the array list. So we say ret.append count and reset count to 0. Yeah, we reset count to 1. And then at the very end, we have to handle the last case. Yup. And then we just return it. And I guess if there's a failure in here, we should de-initialize our array list. So we can say defer ret.dinit. Okay. And let's just do a run length encode sanity tech. So here we can do something like var alloc is std testing allocator. We run length encode, something with allocator, and let's make some iterators. So we can do like struct buff iter. I don't know if this exists, so I'm just going to make it. We have like some buff, which is a bunch of U8s or something. Doesn't fucking matter. And some index, which is a usize. And we'll just make our function, pub function next, who returns a U8. He takes in self by, I guess, I don't know if I can use, const buff iter is equal to struct like this, okay. And here I just say, if I is greater than buff len or equal to, we return null, stop iterating please. Otherwise, we say I plus equals 1. You do constant the argument. Yep, good point. Then what? Buff I, and we return red. Easy. So now we can construct this guy where we say buff iter with some arguments where we have var buff is equal to an array of U8s who are like 0, 0, 0, 1, 1, 0, 1. Sure. And so we can encode this thing. So we can say buff is equal buff, I is equal 0. Probably we need to put an ampersand here. And now we can say std testing expect equal slices. We can expect this U64 output. And we can expect this to be, we had 3 zeros, 2 ones, 3 zeros, 2 ones, 1 0, 1 1. I guess we're kind of saying that we're only encoding the count of, like, if this thing took in anything that wasn't ones and zeros, this output would be kind of meaningless. So you could like assert that the output is Boolean, but I don't really give a fuck. It's fine. It's fine. And we can just check this against RLE items. And we'd write try here probably. Undeclared identifier buff iter, which means that we have to do const self is equal to and this. Something something generic type. I'm not really sure how like the type resolution works because this doesn't always happen to me. Like in structs where it's not generic, I could just use the name and I don't know why it's different. I've forgotten a lot of keywords here. There we go. There we go. There we go. And can I do like zig build test? Expect equal slices. Expected 3 arguments, found 2. Oh, I probably have to specify the type here. Oops, that const won't work. That's also a good point. Because I'm incrementing the iterator. You tricked me. Why did I just believe you? Okay. Found thing. Expect. Oh, because this is const here. This needs to be. Oh no. Expected type buffetter. Found const buffetter. What am I missing here? Var buff iter. Run length encode. He gets anything. Oh, this has to be a pointer to an any type. Or this has to be a pointer. Because function arguments in Zig are const, but they'll auto dereference. So if I put an ampersand here, then I can mutate it. I think. Expected type. This found. This. So he expected a mutable pointer, but found an immutable pointer, which is surprising to me. Oh, because this is a function. Okay. Var it is equal to this probably. Probably local constants. Or like function arguments probably get const by default. So here, if I put an ampersand like this, then it should be mutable. There we go. And then 101, we just have this as to be set as a U64 manually. Found out of memory? What am I looking at? Try, ret, append, count. Expected type, array list, blah, blah, blah. Found error out of memory. What the fuck? Oh, because this has to have a little exclamation point on it. Which means that down here, we have to do right, try here. Okay. So expected this output, 3211, found 3121. Did I count wrong? 3211. Found something else. So we just fucked up, I guess. We got 3121. How is that possible? So we start with a count of 1. Let's just GDB our cached test thing, which is, where is the cached test? Oh, here. GDB on this thing. Break here, run. Okay. So we get a value of 0. Can we print IT maybe? Print IT. So at this point, we've expected to go 2 items in. Okay. Makes sense so far. So we've iterated 2. Our count is 2. Great. What does our buffer look like again? It's IT buff pointer. And we want to dereference this and print 7 things. So we have, can I say PX here? So we have 0, 0, 0, 1, 1, 0, 1. And so here we are on count 3. So now we should get a 1. We do. Okay. So we append count. So and we reassign it. So our ret at this point has 1, 3 in it. So that's correct so far. But that makes sense because we got that correct. So it's the next one that's fucked up. The next element does the wrong thing. Okay, so we have a count of 1 right now. And we have seen 1, 1. Val is 1. Oh, we didn't fucking update the previous. So here we like reset count, but we don't say prev is equal to val. And so we're like just comparing against the wrong value as we iterate. We were kind of like always assuming that the last character was a 0 when sometimes it's not. Unit tests are so sick. Sometimes. I leaked something, so defer RLE deinit. Cool. Cool. Okay, so that's working. Okay, so now what we can do is we can create a like iterator for pixels for a given width for a given line of the QR code. Yes, I think that's right. So we can do something like how do I want to do this? How do I want to do this? Const width how do I want to say call it like width iterator, but that doesn't seem right. Horizontal iterator. Yes. And so he, by our definition, needs to have this sort of like next function. And he's going to take in a horiz iter. Like Danny DeVito in Always Sunny, always talking about his horiz iter. Dinner time, thanks for the stream. Yeah, have fun. Enjoy. So this is what I was talking about earlier, by the way, where I don't get why this is a valid type here. Because like in this structure down here, he was kind of saying like buff iter, which is defined as a constant inside the function, doesn't exist yet. So I guess there must be some sort of like top level resolution that happens before going inside or something. I don't know if that was like a set of words that makes sense, but I'm saying like identifiers at the top level I think might get resolved before anything else, but only at the top level or something. Okay, so I guess what is this guy going to do? He's going to take in the image, and as well as its width and its height. He needs all three. And then he needs his X position. And as he iterates, he's going to say that the value is equal to, I think here I want to say this is a pointer to an array so that I can do image indexing like this. And then I can just do self height times y. I guess I need to know which line I'm iterating as well. Or you could just kind of bake that line into the image. Yeah, let's do that. So we can like just adjust the pointer that we're looking at. And actually we can turn this into like a proper slice. So really we could get away with this. Nice, I like that. And so we can just say self I plus equals 1, return val is greater than 128, right? Because we want to say, hey, we are checking for black and white. And here we're just going to look at line self I. Yeah. Cool. Simple. Simple. And then maybe we take like a function in it who's going to take in the more complex thing. So he's going to take in an image, which is a pointer to U8. Width is a usize. Height is a usize. And then we're going to look at y. Which y index we're going to take in. And here we're going to say that the line is going to be image sliced from height or width times y. I guess we don't need height taken in here. Oh, we do. No, we don't. to const start is equal to width times y. Hello, where is my fucking cursor? There we go. And the end is equal to start plus width. Yep. Yeah. Yeah, that looks good. That looks good, baby. And then we could just say return line equals line and I equals 0. Okay. This guy needs to return something, so he's going to return a horiz iter. Horiz iter. Okay. And then we can just call this guy for each scan line. So we'll say, I guess for each height, we're going to construct a horiz iter with image width, image height, and y. And here we can say for while it next, and this should give us the same thing. So that should mean that if we see a valid QR code printed to the screen, then we are chilling. Image width, oh here, let's choose image width y. Here we go. Incompatible types, usize and bool. Right, because here we just have to say is white. And we'll here we say if is white. So here I think that we should see the valid QR code still. He doesn't like that for some reason. Index out of bounds, because we've got the null check. If I is greater than or equal to self line len, return null, and this has to be self.i. Boom. Okay, and does that still look like a QR code? I think it does, which means that this is working. So now we can try to run length encode each thing. So we can say like run length encode, given that alloc and our iterator, which I guess has to be a pointer to a mutable thing. Let's comment this out for now. I guess we'll keep this in like this. And let's print out the run length encoding. Let's just see. See if it looks reasonable. I think I write dot items here. I have to write try on the run length encode. Okay. So what we're seeing is the first few lines have full white, right? So that's like here, white, 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 white. And then we have some sections where we have 8 white. What is this 828? Oh yeah, so this is the 28. That's this line here. So he's got 8 chunks of white, 28 black, then it should be like more like 8 white again. 4, 4, 8, 4, 24, 20. Yeah. So that's this line here. And we have 1, 2, 3, 4 lines that are making up this black section here. Cool. Seems like that's working. And so now we just need to look for the pattern of what is it? 1, 1, 3, 1, 1. So we're looking for something like, it should be like here. 24, 12. So we're looking for, oh, maybe even past these guys. Here we go. This is it. 1, 1, 3, 1, 1. Right here. Right here. So we have 4 black, 4 white, 12 black, 4 white, 4 black, which is ratio of 1, 1, 3, 1, 1, which is really good. So we can do something like we can say find, we'll call this like matches. Okay. And I guess we want to like iterate over windows of the RLE. Yes. So we want to like look for chunks of 1, 2, 3, 4, 5. We're going to iterate over windows of this and look for sections where 1 and 2, 4 and 5 are all close to equal. Maybe not exactly equal, but close to equal. And that 3 is approximately 3 times larger than the rest. Yes. So here maybe we'll make like a finder candidates. Okay. And we'll take in run length encoded values, which is going to be a const u64. And we'll return a std array list of pixel positions. Yes, so we'll say ret pixel positions. Okay. So we're going to say if RLE len is less than 5, we'll return nothing. So I guess we need to have a thing to return. Allocator. If it's less than 5, we just return red. Now we can iterate for the end value is going to be RLE len minus 5. Cool. And so now we can iterate for 0 to end. We have some value I. And we want to look at RLE for j, or I to I plus 5, I guess. We'll take out some j value. And we will look at RLE j. No, I don't want to do it that way. I want to do if RLE I plus 2, the center one. Well, let's see. We'll go with reference value. Okay. And we'll say for, okay, if RLE I plus 2 divided by the ref value is not equal to 3. Continue. This is not what we care about. And then we're just going to say if I plus 1 is not equal to ref. Yep. Continue. And I guess we just do them in order. 1, 2, 3, 4. And we have to do a little fix me here and say allow for any amount of error. But for now we have like a perfect QR code. So this should be fine. And then we should have some candidates. Okay. Yeah. Oh, wait, this is... Oh, yeah, this is right. This is right. Now, what would be nice is if we could tie this back to the location... the, like, position in the original input. So maybe our run length encoded thing needs to return something a little more complex. Right? He's going to have a start as well as a length. And maybe even then we could keep a value in here, but we're not going to use the value right now, so we don't need it. This guy's going to return RLE items now. And every time he appends here, he's going to say that the length is count. But the start is something else. So it's let's see. So here we have a value as well as a position. But that's only for loop syntax. So we'll just say var pause equals 1. Every iteration, we have to do pause plus equals 1. I guess maybe we are worried about early continues. We could do defer pause plus equals 1, which is kind of fun. That's a cool little nifty trick. And the start will just be at pause minus count here. Yeah, cool. And so now our run length in code, we need to test now that these are RLE items, and it should be like start 0, count 3 is our first thing, right? 0, 1, 2. Then the next thing should be at start equal 3, count or length is equal to, I think is the name of the field here. So we'll start at 3, length of 2, then start at 5, length of 1. This should be start of 5, length of 1, and then start at 6, length of 1. Yeah, and then how do we want to, maybe we indent all of this and pull this guy down like that. Okay, zig build test. Probably won't compile. 162. Right, so this has to say RLE item here. Okay. Comp time int needs to be set to usize so that he knows how to increment himself at runtime. 181. This needs to have one more of these guys. Boom. Test is not quite passing because expect equal slices is expecting U64s, but it's RLE item. I don't know if it's going to let me compare those. It looks like it is. And then let's just introduce a bug just to make sure that the test is actually running. Sure is. So we are chilling. Big chilling. Okay. So this guy now, Finder Candidates is going to take in RLE items. And I guess he's going to return RLE items. Does that make sense? No, he's returning... What are we even pushing in here? We need to push in... This is his X position. I feel like I'm doing something wrong here. RLE item dot length is what we're supposed to be comparing on all these guys. Okay, boom, boom, boom. And then I guess we just push in. Our candidate is going to be the center. I guess we'll call it the center. So we'll say stood. We'll say ret append. We have to try, which means that this needs to be failable. And we'll just append RLE I plus 2 start plus RLE I plus 2 length over 2. I think that'll give us the center. Not really sure. And then at the end of this, we just return ret. And then when we are iterating, we can say, hey, var candidates is equal to finder candidates given some allocator. And being AFK, but are we using RLE to find the QR markers? Yeah, exactly. Exactly. We're looking for patterns of 1, 1, 3, 1, 1. So we have some candidates, and we have to pass in the RLE items here. And this has to be try. And then we can iterate over each candidate. We have to defer deleting of them. And what we're going to do for now is we're just going to slap a circle on each candidate and see if they come out in the right spots. So for each candidate, we're going to draw a circle at the candidate position, the Y position, the radius we're going to make a little smaller than it was before. Let's just see what that does. Zig, build, run. So expected type F32 found use size, so we can say int to float, I think. Built-in, invalid built-in function int to float. Is it float? Float from int. Wow, that was a weird fucking autocomplete. Okay, and then we need to do that here as well. Float from int y. Okay. Oh! Okay. So that's really solid. So we're seeing that here we're getting good candidates down the center of each of these guys. Here there's something else going on. I don't know what the fuck's happening here. Let's take a look. So first of all, let's make the radius of this thing a little smaller. Okay, and so here, this is actually valid, right? Because we're seeing 1, 1, 3, 1, 1. But the colors are in... Oh, they're even the right colors. So that's pretty interesting. So for each candidate, like we have to pick like the best ones. Okay, well, let's start by finding the candidates vertically as well. And then we can try to do something clever like find intersections of vertical and horizontal candidates. And then that will give us maybe a better, like maybe that will filter this out. So here, let's make a vert iter. And he is going to have to take in the whole image this time. He has his index here. He's going to have to store the width. And I think that's probably it. So his start, there's no slicing of the image that has to go on. The image is just the image. There's going to have to be some like casting done to turn this like pointer view weights into a slice. I guess here we just won't bother. Oh no, we can, this should be pretty easy. We have width, height, and which x value we want. So here we're gonna have to say our x offset is gonna have to be stored. X offset is just gonna be equal to the x value. Our image is gonna be sliced from 0 to width times height. Our I value starts at 0, and the width is stored. Okay, so now as we walk this guy, we are going to, if I is greater than, okay, we'll say const index is equal to self.I times Ooh, we can actually do something crazy here. We can get clever. We can get clever. We can store index here is equal to x offset. Yeah. Source x, I guess. On each iteration here, we're going to increase IDX by width. And then here, we can just say if IDX is greater than the image len, we give up. Otherwise, we just look at the image at index. Look at that. Yeah, that's kind of nifty. That actually kind of works out pretty well. Okay, so now let's do the same thing where we iterate over. We'll do the same loop here, but now we have to go for 0 to image width x, and we are going to create an iterator that is a vertical iterator. And this guy takes in the image, the width, the height, and x. And the float, this is going to have to be from x. This is going to be candidate. And maybe we'll make this one blue or something, just so that we have something different. Something here. Oh, this guy has to say vertitor as well. Okay. That's not bad at all. Not bad at all. Okay, so there's this shit where my glasses, I have like really, really fucking thick glasses. I wonder if, I can't tell if you guys can see that at all because I can't see. But my prescription is like, it's like legally blind level. It's like, I don't know what metrics everybody around the world uses, but it's like somewhere in the range of like -11 or 1100, right? So I don't know what that means though, because what you can see at 20 meters, there's no way I'm not seeing that at 10 meters. Like it's like my hand is blurry until it's like right here. Like, but anyways, that ends up really bending light that comes in because they're so thick. They have this like kind of like curvature to them. And what actually happens is different frequencies of light bend into my eyes at different angles. And so if I move my head left and right like this, the red is actually like sliding around my screen relative to everything else. And so that's why I was like doing this a little bit. So I'm just like, what the fuck? Like I can't tell if it's centered, which is pretty funny. It's cool too. If I have like a red light and a blue light on top of each other, they actually like alternate directions when I turn my head. So you get this like weird thing where you could only tell if they're lined up by if it makes a vertical line. It's really fucked. It's like this, the idea that like my experience of reality is like so twisted by just this is like it's very interesting to me. Okay. So I guess what we want to do is we want to filter our candidates to where the X and Y intersect. So we can just say, maybe we do something like, we call this vertical candidates, like stars and redshift. Probably that's star redshift. It probably is very similar. Yeah. Increase in wave. Yeah. Except, well, I guess it's not the same because this is talking about like the color, the frequency of the light changes based off of the speed that the thing is moving away from you. Is that what this is? Increase in wavelength. It's like Doppler effect, but for eyes, right? Oh, refraction. Oh, so it's like bending around a planet and then you see a different color or something? Redshifts, blah, 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 blah. Perceives as X-ray, blah, blah, blah. I want to know, like, why. Arrows indicate redshift. Distant galaxies as compared to absorption lights from... Oh, okay. So I thought it was going to be, like, related to movement or something. Frequency stretching. Yeah, no, I understand the idea that like the red is changing frequency because it's stretching, which isn't what's happening to my eyes, by the way. It's like, well, maybe it is a little bit, but mostly it's about like the actual physical position of them. It's more like a prism. Anyways, we're getting distracted. We're getting distracted. So here we're gonna have vertical candidates. Maybe we'll just have all candidates. Refraction affects different colors differently. Yeah, for sure. All candidates is going to be an array list of points. So we're going to have a point that's like X and Y. Const point is equal to struct. Yeah. Okay, so we're gonna have vertical candidates are going to be points. So this has to allocate or init with an allocator. And then we have to vertical candidates init here, okay. And let's say that for each thing here, we're gonna say vertical candidates append a point with a specific X is equal to X, Y is equal to candidate. There we go. Candidate. And we're going to do the same thing down here for horizontal candidates. Yes, I think this makes sense. Candidate, which means that we also need horizontal candidates over here. And then at the end, we can just look for points that are in both. So for candidate, so for vertical candidates, we have vert candidate. And then we go for horizontal candidates, horiz candidate. Okay. And then we just say, if, are we allowed to just memcomp here? Stud mem. Is there no like, oh, there's equal. But that's for like an array. Can I like, is there zig compare structs? I guess we'll have to do like a bytewise compare because it seems like that's legal. Stud meta equal. But I feel like stud meta equal is going to do something too crazy. Stud mem equal, I could like cast it to a byte slice. So I can do like stud mem as our byte stud. There's like stud mem as bytes. Vert candidate. I could do this, but I don't think I want to. We'll do stud meta equal, which is gonna like walk the structures fields and do equality comparison. Wee woo quadratic algorithm alert. Yeah. But how many points are really gonna be in here? Not a lot. So fuck it, I guess. And then we have vert candidate and horiz candidate. Oh, both of these have to say items here. That's why the type resolution isn't working. So does this return a bool? Yeah, it does. If these are equal, this is when we draw a fucking green circle. Wow. Vert candidate. I think stud mem as bytes needs well-defined mem, so external pack struct. Yeah, that wouldn't surprise me. That's why I kind of stopped going down that route. Here we go. X and Y. So if we refresh this now, we should see a green dot in the center of each of these. Hell yeah. We'll make the green dot bigger. just to really hammer the point home. Look at that. That's so sick. Dude, that's sick. We found the finder path, we found the position markers. That's so fucking cool. That's so cool. Okay, and I think that like spending the like what 30 minutes or whatever we spent on like visualizing everything here is like so nice because now you can like we see stuff like, oh look, here's like some possible candidates that like, and we can like see the intersection visually. It's so sick. Yeah, I'm really happy with that. Okay, so we're at an hour 55. So I think that this is like about as perfect as we're ever gonna get. Like a really nice, solid visual thing. Feels fucking good. We got like, yeah, this is like a good ending point. So, thanks for watching, guys. If you like what you saw, we stream most days at around 2 o'clock Pacific time. Right now it's 4 o'clock Pacific time, so anywhere between 2 hours ago and now. F. No, is the stream dying, or are you just saying F because you don't want it to end? Either way, yeah, so there's a YouTube link and a GitHub link in the Twitch description where all previous projects are going up. So source code for this will get there eventually. And then on YouTube, there's playlists for all of the various things we worked on, like terminal emulator, operating system, neural network, web dev, virtual file system. There's like a bunch of stuff in there. So if you like what you saw and you want to see more, there's stuff in there. If not, I don't care. Do what you want, you know? If you're on YouTube and you made it this far in the VOD, there's a good chance that you're gonna want to see live, maybe. So there's a Twitch link in the YouTube description if you want to swing by, say hi. Otherwise, catch you on the next one. Bye.